Hi everyone, welcome back to my channel. This is Mr. Budehas, your online math teacher. In today's video, you will learn set operations. At the end of this lesson, you will be able to accurately list the elements of the union, intersection, difference of two sets, and the complement of a set. Let's start. Let's learn first the union of sets. It is the set that contains all the elements of both given sets A and B. The union of sets A and B is denoted by A union B. For example, if set A is equal to A, C, E, and set B is equal to B, D, F, then A union B is equal to A, B, C, D, E, and F. Just write or combine all the unique elements from set A and set B. If we are going to represent this one in a Venn diagram, we have this. First, we will draw the universal set, then we have set A and set B. Since they don't have common elements, then they are disjoint sets. We have A, C, E, and B, D, F here. This is our universal set. This is set A and set B. Then our A union B is this one. Just shade this set A here, and this is set B. That is our A union B. Another example, if set A is equal to 1, 2, 3, 4, and 5, and set B is equal to 3, 4, 5, 6, and 7, then A union B is equal to 1, 2, 3, 4, 5, 6, and 7. Again, just write or combine all the unique elements from set A and set B. In Venn diagram, we have this. First, again, we'll draw the universal set. Then, look at the given elements of a set. We have 1, 2, 3, 4, 5, and 3, 4, 5, 6, 7 for set B. Then, since they have common elements, then we will draw an intersecting sets. We have 1, 2, then 3, 4, 5, 6, and 7. For the A union B, we will shade this since we are going to combine all the unique elements. And that is our A union B for the intersecting sets or the joint sets. Again, this is our universal set, this is set A, and this is set B. Next, we have the intersection of sets. It is the set that contains all the elements common to both given sets A and B. The keyword here is the word common. The intersection of sets A and B is denoted by A intersection B. For example, if set A is equal to 1, 2, 3, 4, and 5, and set B is equal to 1, 3, 5, 7, and 9, then A intersection B is equal to 1, 3, and 5. Just write the common elements to both sets A and B. Here, the common is 1, 3, and 5. In Venn diagram, we have this. We'll draw first the universal set, then the sets A and B. This is set A and this is set B. For set A, we have write first the elements that is not common to both, then the elements that are common will be written here, 1, 3, and 5. Then for the other side, we have 7 and 9. So the A intersection B there is this one. That is A intersection B. Next example. If set A is equal to 2, 4, 6, 8, and 10, and set B is equal to 1, 3, 5, 7, and 9, then A intersection B is equal to this one. Or we can have this symbol. It means there is no common elements. This is null set or empty set. If we are going to draw this one or represent this one in a Venn diagram, we have this representation. This is the universal set, then set A and set B. Since there is no common elements, then they are disjoint sets. You have 2, 4, 6, 8, and 10 here. This 1, 3, 5, 7, and 9. Again, this is set A and this is set B. Then we have this universal set. So our A intersection B is null set or empty set, since there is no common elements to both sets A and B. Next, we have the difference of sets. It is the set that contains all the elements in set A which are not in set B, or the elements in set B which are not in set A. The difference of sets A and B is denoted by A minus B. We can have also B minus A. Later, I will give you an example for that. For example, if set A is equal to 1, 3, 5, 7, and 9, and set B is equal to 1, 2, 3, 4, and 5, then A minus B is equal to 7 and 9, because that's the only element that we cannot in set A that we cannot find in set B, or in set A which are not in set B. If we are going to draw that one in a Venn diagram, we have this. This is our set A and this is set B. The elements in set A, first we will write the elements that is not common, 7 and 9. Then the common elements we have 1, 3, and 5. Then for set B, the unique element in set B is 2 and 4. So if we're going to find or shade the A minus B, there is this one. This one only. So A minus B is equal to 7 and 9. Of course, we will not include 1, 3, and 5 because we can found that elements in set B. Next, we have B minus A. I will be using the same elements. For B minus A, the answer would be 4 and 5. Oh no, 2 and 4, sorry. That is 2 and 4. 2 and 4. Because 2 and 4 are the elements that we cannot found in set A. Now, if we are going to represent that one in Venn diagram, we have this. I will be using the same Venn diagram, but I will be using another color for B minus A. For B minus A, that is this one. The red color is our B minus A. Next, we have the complement of a set. Complement of a set. It is the set that contains all the elements in the universal set that are not in set A. The complement of set A is denoted by A prime or A complement. And the other books or the other author, they use this symbol A complement. For example, if the universal set is equal to 1, 2, 3, 4, and 5, and set A is equal to 1, 3, and 5, then the A prime or the A complement is 2 and 4. Because those are the elements that we cannot found in set A, but we can found it in the universal set. Now, if we are going to represent that one in Venn diagram, we have this. This is our universal set. Then we have set A here. Set A is equal to 1, 3, and 5. Set A. So we have to shade now the A prime. This is our A prime.